Hi, my name is Edwin Chen, and I'm the co-founder of Legacy AI. Over the past year, we've been helping more than 50 different companies to eliminate their operational bottlenecks through our chat, voice, and AI automation workflow solutions. And in today's video, I would like to present to you a new framework that we formalized during our Google Gemini hackathon a few days ago and wrote a paper on it that could potentially change the way that we think about designing agentic AI systems. It's called Machine Learning as a Tool, or MLAT. We went this over in our Google hackathon submission and submitted a paper on it as well. Think about it. 2025 was the year of AI agents. Your LLM agent can call Google Search Weather API to fetch the latest weather results. Frameworks like LangChain, Llama Index, AutoGen, CrewAI, NTN, they've all formalized this. Multi-agent systems are pretty much everywhere now. At the same time, we've also been seeing machine learning models since a long time ago that can do prediction, fraud prediction, demand forecasting, price prediction. These machine learning systems are getting deployed across every single industry. And if you don't know what machine learning model really is, it's essentially a pattern recognition done by computer systems. For example, if you want to predict the prices of houses, you can feed it with features such as how old is the house, how big is the house, what materials is the house in, what location is the house based on. And based on thousands and tens of thousands of these examples, there are algorithms, statistical models that can learn these patterns. And if you give them brand new house information, it can basically use that model to predict the houses based on these trained examples. But here's what I noticed. The two technologies, machine learning models and LLM agents, they almost never work together in the same production settings. And we find that it's a massive gap because for many critical tasks, pricing, risk assessments, statistical machine learning models trained on historical data actually outperforms these large language models like ChatGPT at quantitative prediction and numerical reasoning and maths. But these LLMs excel at contextual reasoning and natural language generation surrounding those predictions. And nobody's building a system where the AI agent can call the machine learning model as a tool, just like a Google search tool, reason about the prediction and use it to make decisions in real time. So I formalized this pattern, published a paper on it in our Google Gemini hackathon, and validated through a pilot production system called Pitchcraft that we use every day in our AI agency. Pitchcraft is an end-to-end automation solution that can take any discovery call recordings, analyze the transcripts, and then output a full proposal with pricing and quotations attached to it using a machine learning model that's trained on our agency's data. It eliminates the entire proposal writing process from a week to less than 10 minutes. And it can extend easily to other quote-based business like constructions, for example. By the way, Pitchcraft is going into beta soon. You can use the link in the description if you want early access with free tokens. But in this video, I want to go deep onto the framework and theory surrounding it. I'm going to break down what the MLAT framework actually is, how it is different from traditional ML pipelines and LM agents, and explain why it matters and what makes it so special in agentic AI. So let's dive straight in. I would like to call this framework machine learning as a tool. It's basically more like a design pattern, to be honest. And to understand that, you will need to actually understand what a AI agent is and what traditional machine learning really is. For those of you who don't know, I'm just going to go over this very quickly. So what is an AI agent, right? If I know it's 2026, but it's quite silly that if you ask 10 people and 10 people will give you a different response. But for me, an AI agent has three components. It has the brain, like ChatGPT, a large language model that can process information. And attached to the large language model, like ChatGPT, is two things. One is memory, so it will remember a lot of past conversations and use that as context. The second thing is tools. Now, this is very important. Tools allow what AI agents to do real world things, like booking appointments and saving leads. For example, I can attach a weather API, which is just a way to communicate information, like a weather tool, to be able to get the current weather by connecting the tool to the brain, which is the ChatGPT. This is what a LLM agent is. Whereas for machine learning, it has been around for so long. It's basically a field of AI, but it's been around for the last 5-10 years, I would say. It uses a lot of statistics and maths. As an example, if you have a machine learning model that can train any input to classify whether it's an apple and an orange, right? It's very simple. It's just classification. So if I provide it with an apple of image, what it's going to do is going to extract something called features. So what that really is just breaking it down to the properties of the data that you just inputted to it. In this example, it's an apple image, so there are different things that you can extract. For example, the color is red, the shape is spherical, for example. These are features, or you can extract from like the images more specifically, like the eyes of the apple. There exists the apex, there's like the stalk, right? An apple is a stalk, and then you have a base, etc. These are all features. So the model will extract this kind of features, and it will pass it to the classification algorithm that has been trained on like thousands, if not tens of thousands of, let's say, fruit images. So it will be trained on apple images, orange images, grapes images. And once you pass the features to this machine learning classification algorithm, it will output say, oh, oh, this is an apple based on my training example. What it's doing really is pattern recognition on like a large scale. Patterns that only computers can really see and map, but humans can't really do that. I mean, they can for Apple, obviously it's a simple use case, but if it's like for a harder use case, for example, for prediction, there may be features of like how old is the house, how big is the house, where is the house actually located. These are also features but used for, rather than a classification algorithm, it passes through a prediction algorithm of a machine learning model like regression, which can then predict the price of the house based on these features. This is traditional machine learning. But what we've discovered is that there's not many people who are using both at the same time, which is very surprising to me because, as you all know, large language models are bad at maths. What if we have large language models which are bad at maths but very good at reasoning and contextual reasoning and natural language generation, combine that with the statistical backed model that have been trained using classical statistics and put it together in a design pattern called machine learning as a tool, meaning that the ChatGPT, the brain, is still processing the text, but instead of like the weather API, we're plugging in a machine learning model like a classification model that's been trained or a prediction model that's been trained as a tool, meaning wrapping this model around in an API. For example, wrap a trained prediction model in an API as a tool call. So the ChatGPT can just call this tool like it calls the weather tool. In a use case like quote or price prediction, it can then predict the price in real time through calling this API, which has been trained. So rather than asking the LM to be like, based on this context, let me guess the number. But as you know, ChatGPT is very bad with maths. That's why we're using this to actually give an accurate number. The advantage is that the LM can decide when to invoke the machine learning model, so when to invoke this tool, because this is just a tool call. And after this machine learning model outputs a number, it can then go back to the brain and actually reason, does this actually make any sense or not? In traditional machine learning model, you can't. You get an output, it's an apple, great. What if it said it's an orange and gives an error? Then you can't do anything about it. You just got it wrong. Whereas here, the LM ChatGPT has the reasoning capability, well, quotation mark reasoning, but still quotation mark reasoning ability to kind of know that, does this actually make sense or not, and actually output the final answer to user. That's the advantage that we're proposing. And we've actually published a paper on this during our Gemini and Google hackathon. If you want to actually go through this in more detail, you can use the link in the description to read for free. We basically formalized this design pattern a little bit better with like a definition, as I said, design pattern, where pre-trained machine learning model is exposed as a tool within an LLM agent, enabling the agent to invoke the model during the reasoning process, receive the prediction like a tool response, and actually incorporate it into its output through contextual reasoning to see if it makes sense or not. But you can see the difference between the MLAT versus like kind of just a static different pipelines, right? You're probably familiar with traditional machine learning pipelines, which is just pre-processing, and then you call the machine learning to do some pre-processing, and then you call the LLM afterwards. And there's really no contextual reasoning. You can run it in parallel with the LLM, but the reasoning is kind of limited. Or you can do it through RAG. You probably know about this, which is basically you have a knowledge base, and then you just find the semantic meaning of the text and call it back. And this is not really what we're doing. We are calling the tool, which is the machine learning model, the agent to initiate the tool call, and to do a full reasoning loop after the machine learning produces a number. The LLM interprets the results in real time. Again, which basically says the agency decides when and how to invoke the ML model and can reason about the prediction before incorporating it into the final output. We actually built Pitchcraft. Basically, it can take any discovery call recordings, like Firefly's recordings, and can actually research the prospect and analyze the discovery call a trained model that has been trained on our agency's deal. So like how much we should price based on certain vectors, predict the price, reason if it's correct or not, and then write a proposal end to end back to us. So we actually use this tool like almost every day now. But if you're an AI agency owner, by the way, if you want to get access to Pitchcraft, which should be going out in beta very soon next week, you can use the link in the description to essentially sign up to get free access. This can be applied to any use cases that need price prediction or quote prediction. For example, construction business. Imagine you have a WhatsApp agent that you can talk to in real time, but also when the customer say, hey, how much is the project? It can give us an accurate quote immediately rather than waiting 2 weeks or 3 weeks to do all the formulas and the math. You can just use a model to actually do that. So what we've done is we have the discovery call recordings, which is the Fireflies. We basically feed it to a research agent, and then it has to use the Gemini, and then it has memory. Then we have two APIs. One of them is called Firecrawl, and one of them is called Perplexity. Both of them are research API. So what we'd actually do is that based on the prospect name and the company name, this will look up the annual revenue of the prospect, so like how much they're earning. This will look up company general information, what product and services they're selling. And what this agent does is actually returning in a very structured output, aka in a JSON format. And this is what the structured output looks like. So if you don't know what this is, it's just a JSON. So basically it has a key. So for example, client revenue, 1 million. How long the project is going to take? 8 weeks. Integration complexity from 1 to 5 is a 4. Of course, during the agent, I explain what is a 1, what is a 2, what is a 3, what is a 4, what is a 5, right? Pain score, so how painful it is to the client and the face of the client and kind of what tech stack we're using. This basically forces the agent to output something that's really structured. The reason why we need a structured output rather than just like a free text is because we need to use these values here to call our machine learning model. Because remember, our machine learning model takes structured output, takes features to feed it back to the algorithm. So that's why we need to force the agent, the LLM agent, to force the structured output. Now we're back to the draft agent. This basically write the proposals. The tool it has is price prediction, which is a trained machine learning model called gradient boosting that we use essentially to predict the price based on these factors to predict the price of the project. Now, you might be looking at this and be like, oh, what is this R square? What is this R square? What does it mean? So all you have to know is how close is the predicted price to the actual price. So you can see these dots, right? So it's predicted price against actual price. This line basically means it's perfect, aka the predicted price from this machine learning model fits exactly as the actual price. So if we have a 0.937, it goes from 0 to 1. Think of it from like 0 to like 100%. So if it's 0.937, it's basically 93% there, around 93% there. So basically, as you can see, the dots are pretty close to the line. That means that the predicted price from this model are quite close to the actual price. And this is kind of the test set. There's the training and test set. Again, I don't want to go too much into the machine learning part of it, but as you can see, basically, this number just shows you how close the dots to this line. So basically how close the predicted price is to the actual price. And this is the actual training. You can see that we use something called cross-validation. If you don't know what this is, don't worry about it. But it's basically kind of like a small data. So that's why we use that. And you can see these are the R square. So basically how close is the predicted price to the actual price here. And yeah, you can see the mean errors and everything is documented properly in the paper based on this code. So you can just read the paper to go through the results if you're interested. But the whole idea is that this machine learning model gives you a pretty good estimate of the price. And then once that's done, it feeds back to the agent and the LLM will reason, okay, this project costs, let's say 5K. And does this make sense? Because the agent obviously has access to the discovery code recordings. It also has access to the client research that's been done by the research agent and has access to these kind of data. So it will reason, does this actually make sense? If it does, great. If it doesn't, it might call this tool again and be like, hey, actually, I don't think this actually makes a lot of sense. I might just change the number a little bit and can actually interpret this result with context. And then what this agent is going to do is going to write a full like proposal. So as you can see that it's basically a full proposal like this that's been written by the agent and the human just need to go back to it and amend it. So this is basically Pitchcraft, but Pitchcraft is basically something we built during the hackathon to just validate this design pattern. So hopefully you get a simple understanding of what we mean by machine learning as a tool. And yeah, if you're interested, have a read through the paper, let me know what you think. And if you want access to this Pitchcraft system, again, use the link in the description to get early access. I will do another video on Pitchcraft in a little bit more later. But this is it. Thanks for watching. If you enjoyed this kind of content, remember to like, comment, and subscribe. And yeah, I'll see you in the next one.